Okay, here we go. So we are actually going to do, not only do these, but we're going to do them in different ways. We're going to use p-values in a table. We're going to use p-values in our calculator, rejection regions in our calculator, and so on, to see if you know how to do this. Did you watch that part yesterday, Thomas, where we did the calculator stuff too? Okay. So make sure you have a calculator out because we definitely will be using it. Okay. So example 1. A researcher claims that less than 40% of U.S. cell phone owners use their phone for most of their online browsing. In a random sample of 100 adults, 31% say that they use their phone for most of their online browsing. Out of curiosity, raise your hand if most of your browsing and shopping is done on a phone. 1, 2, 3, 4, 5, 6. Interesting. 31% say they use their phone for most of that. Alpha equals 0.01. Is there enough evidence to support the researcher's claim? Okay, so let's start identifying what these things are. This is the claim right here, and that's going to be your P. This one is your sample proportion. That's P hat. Remember from last chapter? Okay, so first we have to verify that we can do the problem. Is n times p greater than or equal to 5, and is n times q greater than or equal to 5? This is something that you need to check on your own statement, and you might need to get a few more data points to make it work, or you could always not make it work, and then in your errors say, look, this really shouldn't be valid anyway because I shouldn't have been able to do this in the first place. So they asked 100 people. And n times p, notice this is not p hat, this is not the result, so this is what your guess was, that 40%. So 100 times 40%, is that greater than 5? Yes. And 100 times 60% is also greater than 5, we're good there. Null and alternative hypothesis, H sub O, H sub A. All right. A researcher claims that less than 40%, so where should I put it? Less than 40%. Null or alternative? Yep, so P is less than 0.4, and over here it's P is greater than or equal to 0.4. This is the claim. I haven't done any quizzes this chapter with you guys, so I'm hoping that we're all clear and understanding before you go into your projects about how to decide the null and alternative. If you want some help on your project, I am not going to do the thing where you hand me your whole project and say, hey, can you look this over and see if I got 100% on it? Nope. But if you say, can you look over this part of it and make sure my rejection regions are right or make sure this is right? Absolutely. I'd be happy to look at something specific. I'm just not going to look at your whole project. Sketch and determine the critical values in the rejection regions. Okay. So this is a left-tailed test. I made this area too big because alpha is 0.01. With proportions, you use A16 z-scores with it, not t-scores with it. So you're going to need out A16. Okay, so you're looking at 0.01 in the middle of the table, which is negative 0.233. That's my rejection region. That's my edge that I'm accepting. The formula is p hat minus p over, this is kind of looking like they're all looking familiar now, like x bar minus mu, right? P hat minus p. On the bottom is that standard error, which is p times q divided by n underneath the square root. Okay, so p hat was 0.31 minus 0.4 over the square root of, what should I put underneath the square root? Should I put 0.4 or 0.31 as my p? 0.4, because it's not p hat, it's p. Yep. So 0.4, what's q then? 0.6 divided by 100. Make sure you put parentheses around the top. Go ahead and put this in your calculator. I got negative 1.84. Tell me if you guys get the same thing. Get it? That means that hit about here, which is in this null area. So what do you do if the z-score hits in the null? Do you accept or reject the null? Accept, yeah. So we're going to accept the null. And in this case, that means that we're going to reject the claim. That less than 40% use their cell phone for most of their browsing. Okay. Now, on the side on this problem, I want you to write that this is an example of using rejection regions in a table. And for the next one, we're going to use rejection regions and your calculator. So there's some stuff we're going to do that is the same and some stuff that is going to be faster because we'll use a calculator to do it. So a researcher claims that more than 30% of U.S. smartphone owners use their phone, shopping, social networking, and so on while watching television. Raise your hand if you use your phone almost always while you're watching TV. Okay. In a random sample of 150 adults, 38% say they use their phone while watching television at alpha equals 0.05. Is there enough evidence to support the researcher's claim? All right, first we have to check that NP and NQ thing. 150 is my N. They're guessing 30%. 30% of 150, is that bigger than 5? For sure. Okay, we're good there. You don't even have to figure out what it is. Just make sure you check. And if you happen to find out, oh my gosh, it turns out my whole project is nonsense because I didn't have a big enough sample, then you make sure you list that in the errors or try to change it if you can. All right. H sub O, H sub A. Researcher claims that more than 30%. Where should it go? The alternative.